Did you know if you're a farmer, you can get your low tunnels paid for by the NRCS? Through a recently launched government program, farmers can get between $4 and $5 per square foot in reimbursement towards a Quick Hoops low tunnel system. That's free money to help increase production on your farm. Learn more about Quick Hoops and the NRCS program at shop.moderngrower.co or using the link below. So mycelium itself, what is it made out of? It gets culled. It's not producing anymore. It's left in the soil. What is now in the soil when other microorganisms can come digest that? What's it made out of?
Well, the cells of mycelium are pretty similar internally to animal cells and plant cells. So they have eukaryotic cells in basic, biology concepts. Prokaryotes are bacteria with really simple cells, and the eukaryotes are more evolved. Plants have, so animal cells are just kind of like water balloons, and we have all the organelles and the nucleus and things inside that, but we have soft tissue, right? Plants have a cell wall that includes cellulose, hemicellulose, and potentially lignin if it's a more woody plant, and that gives the plant structure to grow upright without flopping over, unless it's a simpler plant. And then, and that's one of the distinguishing features of plants is their cell wall structure. Fungi also have a cell wall, so it's an extra layer beyond the water balloon, the cell membrane that contains the internal components. But their cell wall is different from plants. So its primary compounds are chitin. It's the same compound that makes up insect exoskeletons and lobster shells. So microscopically, it's a very thin layer, but it's still rigid, firm, gives the fungus structure and a bit of protection from the pressures of water or being inside of a log or inside of the soil. And then that's about 10% of the cell wall structure. The other 80 to 90% are high weight table sugars. High weight sugars and not table sugar. So much more complex than fruit sugars or table sugar, a very long chain, high molecular weight, very complex sugars. And sugars are made up of, they're called polysaccharides, and they're made up of monosaccharides, individual units of carbon-rich rings. Tons and tons and tons of carbon. And this is what primarily forms the vast majority of the fungal cell wall is, I don't have the exact percentage, but it's a ton of carbon. A lot of these sugars are actually what we attribute some of the medicinal effects of fungi to. So that's where a lot of that comes from, is some of these sugars. And a lot of that, again, just folds away and is easy to be digested by microbes. It's essentially a sugar. The bond between each of the monomers is the same type of bond you'll find in simple fruit sugars. You just have many of them strung together in one super long chain, whereas simple sugars are just a few of these monomers, and they're fairly short. And so that's a lot of what's left behind. Again, 80-90% of the whole cell wall. A lot of this fungal structure. What makes it unusual or different from other organisms is this material. And I guess just last bit for the people that want all the details on the exterior of it, this is a little bit more, it's pretty interesting. There's also a thin layer of proteins, which are fairly hydrophobic. And so it actually repels water. And it's actually thought that this helps the mycelium glide through its substrate more easily because it's sort of sliding through it and pushing stuff away, which has an effect on the qualities of mycelium as a structural material. It makes it fire retardant. Actually, it makes it more buoyant and things. But maybe that's more of an aside.
No, it's great. I mean, it's totally cool how this all works. And I mean, the remarkable thing about fungi is all these layers, along with other things happening within the organism itself, make it hard to penetrate while it's living. If it culls off, given how kind of the soil cycle works, is a lot of that stuff going to be bioavailable to the other organisms in the soil when it's no longer there? Or are you going to need other fungi to come digest the old fungi so then other organisms can get access to that? Or when it sloughs off, is it kind of fair game for other things in the soil that might want to have targeted it when it was alive, but now it's not?
Yeah, I mean, when the mycelium dies, or even probably when it's alive too and can't fend for itself, really, it only can really defend through the release of chemicals. It doesn't have, appendages or anything like that, or fingers or mouths or anything. Insects do come along, and micro insects and things in the soil, and other microbes will eat the fungal tissue and just chomp right through it. The tissue passes through the digestive tract of the insect, becomes its waste. Other microbes or microbes then come and eat that waste, and here's a big part of the soil web. But generally, the fungi, they can't really fight off insects so much, other than maybe trying to create, noxious compounds and things. Generally, their defense mechanism is, as I said, the release at their growth tips as they're growing. It's a branching network, and at the tips, all kinds of chemicals are being released, including antibiotics, antifungal compounds to fight off other fungi that might want to attack it. There are fungi that do hurt other fungi and can penetrate and kill them while they're alive, which is we can actually talk about that as an important group of soil fungi, and then also antivirals. So there are viruses that can attack fungi, but I like to think of fungi as nature's greatest chemists, and I know a lot of plant folks won't necessarily agree with that, but a lot of the chemistry inside of plants we're finding is actually produced not really by the plant, but at least directly or initiated to a pretty good degree by the internal fungi inside of the plant, and that's just a whole new realm of discovery and a different discussion perhaps, but so they're just incredible chemists, I guess, is a short story, and part of that is exemplified through their ability to defend and adapt and grow in all conditions, largely essentially entirely through the production of their unique host and suite of chemicals.
Hello, growers. Looking to turn your homestead into a profitable business? Or are you a farmer looking to boost your sales? Check out my book, Sell Everything You Grow. This book is the ultimate guide to choosing the right farm business model that fits your farm, time, and location. Discover which model has the highest profit margins and why diversification is so important. Whether you're selling apples, vegetables, or microgreens, Sell Everything You Grow will help you find your first market or expand into new ones. Get Sell Everything You Grow on Amazon and start selling more today.